This is exercise number 5, which is given on slide number 36 of the sampling distribution presentation. As exercise 5 and exercise 6 are more or less same with the few differences. The difference is we have a population size of 3 in exercise 5, and the sampling is done by using with replacement. We have to use sampling by with replacement. While in exercise number 6, the population size is increased. Instead of 257, we have one more element in my population, 257 and 4. And the second difference is we have to do the sampling by with replacement. So that is the difference between the exercise 5 and exercise 6. I will cover exercise number 5 first, and then we will cover exercise number 6. This is somewhat related with the video number 2 of the sampling distribution of mean, but the data is changed here. What the data is given here, the number of defects in the cars of XYZ brand. Assume these are the 3 cars and in my population, which is quite unnatural, but for a purpose of demonstration, we are using a small population so that we can verify the concept of sampling distribution of mean, and all the theorem of the sampling distribution of mean will be verified by using this simple example. So in part 1, we have to draw all samples of size 2 by with replacement, and then construct the frequency sampling distribution of mean defects of a sample of 2 cars. Finally, we have to determine the mean and variance of the sampling distribution of mean and compare them with the population. The size of population is 3 and the size of sample is 2. Size of sample is 2 and sampling is by with replacement. According to the sampling by with replacement, total number of samples, which I generally represent by m, is n raised to the power n, because it is done doing by with replacement, and it is equal to 3 raised to the power 2, and 3 raised to the power 2 becomes 9. It means totally we have a 9 samples to draw, and then we will compute the mean and variance of that. That 9 samples can be written, I think I will use Excel sheet to insert here. In this Excel sheet, we have to write down in the first column as samples. And I am writing the samples, serial number will be the first column. Serial number, as I will draw 9 samples. These are the total 9 samples. The sample number 1 will be based on what? It is based on 25. The first one will be the 22. The second one will be the 25 and the 27. The next one is 52, 55 and 57. The 7th one will be 72, the 75 and 77. These are the different samples. Now we have to calculate the mean of each sample and construct the sampling distribution of mean. The mean of these samples can be computed here. I'm just writing the column mean, sample mean. And the formula of mean is what? Either I can use the function, average function, or I can write down my own formula, that is equal to this plus this divided by 2, as the sample size is 2. And then I will use this formula to calculate the rest of the samples. So how many times I have 2, how many times I have 3.5, how many times I have 4, and so on. So we have to construct a frequency distribution of this. That distribution is known as the sampling distribution of mean. The sampling distribution can be constructed in here I have to write down the column mean, and the unique values of mean will be written here. The unique value of mean is 2. Then we have 3.5, and then we have 4.5. After 4.5 we have one value of 5. Then the next value is 6 and 7. And the frequencies of these will be what? 2 is occurring 1 times, 3.5 is occurring 2 times, and 4.5 is occurring 2 times, and 5 is occurring 1 time, 6 is occurring 2 times, and 7 is occurring 1 times. This is the frequency distribution, and we can construct the probability distribution by just taking the total here. That total should be 9, and totally we have selected 9 samples. I am using a table here. This table is referred to as frequency table of the sampling distribution of mean. In the next column will be what? Probability of mean, or the probability of x bar. X bar is the sample mean here. Probability of mean can be computed as 1 by 9, 1 by 9. Instead of writing 1 here, I am using cell reference. This is 1 by 9, and I am computing the rest of the values here. The total will be 1 or approximately equal to 1. You can see the total is 1. Now we can calculate the mean and the standard deviation of the sampling distribution of mean by making the 2 columns. One column is x bar into px bar, and the second column is x bar square and the px bar. So that 2 columns can be constructed here. Mean multiplied by probability of mean. This is nothing, it is just the product of the 2 columns. This is equal to, the value of mean is 2 and the value of the probability is 0.11. That product will be equal to this, and we can have total. This is the mean of the sampling distribution of mean. It is 4.66. Now for variance we need one more column, and that column is the mean square. Mean square multiply by the probability of mean. This can be taken as superscript, so that the correct version of that here. The formula will be what? The mean square. The value of the mean is 2, and the square of that multiply by the probability. This is the probability. And we have these numbers. Finally, the total will be computed. The total will be shown here. I am using Excel to complete this problem. The exact answer will not be matched. The reason is, if I took the values in the ratio instead of fractions, so we can have the exact proof of these theorems. But I am not using ratios. That is why it is Now this table is referred to as sampling distribution, table of the sampling distribution of mean. And these are the total samples that we have selected by with replacement. These are the two separate tables. Do not merge this table with this one, because these two tables are separate tables. Now you can see the entire Excel file here. And now what is to be do? We have to verify the mean and variance of the population. We have to calculate the mean and variance of the population, then verify the sampling distribution of mean compared to the population mean, and the variance of the sampling distribution of mean to be compared with the population mean. The population mean and population variance can be computed in Excel. So I am again using Excel for this purpose. Our population was based on three numbers. That three numbers were 2, 5, and 7. These are the numbers in my population. Now I'm computing the mean of the population and the variance of population directly by using the Excel functions. The mean will be mean. It can be computed by the formula of average. Average of these three numbers. The average is 4.66. So you can see that it is verified. The mean of the sampling distribution of mean is 4.66, and the mean of the population is again 4.66. So these two numbers are exactly verified, that two numbers are equal. Now we are computing the variance of the population. Variance of population, we have a function in Excel. That function is VAR. There are the two versions of this formula. One is VARP, other is VARS. VARS for the sample, VARP for the population. So I'm using VARP. And these three numbers are identified here. It is 4.2, but it is not exactly equal to these two, because this is not the variance of the sampling distribution of mean. We have to compute the variance of the sampling distribution of mean separately, and then we will compare the variance of population with the variance of the sampling distribution of mean. That is to be completed now. Variance of sampling distribution. This is equal to, I'm using a formula here. And that formula is what? That formula is uh, this minus square of this. The square of this can be written as SQR, not SQRT. We have to use this power 2. This is 2.11 is the value of the variance of the sampling distribution of mean, and the population variance is this. Is there any relationship between these two? So the answer is yes. There is a significant relationship between these two, and that can be verified by the theorem of the sampling distribution of mean. Now variance of sampling distribution of mean will be equal to sigma square upon n in case of with replacement. So your value of sigma square is 4.22. If we divide 4.22 by 2, because the sample size is 2 here, that is equal to the 2.11. Hence it is verified. This number is exactly equal to this number. So you can see that the variance of the sampling distribution of mean, which was 2 point, this was the variance of the sampling distribution of mean. And this was the variance of the population. This is the population variance sigma square. And this is the mean of the population, which is represented by mu. And this is the mean of the sampling distribution of mean. This is mu x bar. So the value of mu x bar is 4.66, and the value of the variance of the sampling distribution of mean is 2.11, and this is the value of the population variance, and this is the value of the population mean. Finally, I am concluding here, according to the theorem, the mean of the population mean is equal to the mean of the sampling distribution of mean. It is verified here. Second theorem is what? In case of with replacement, the variance of the sampling distribution of mean, which is 2.11, it is equal to the variance of population, which is 4.22 divided by n. You can see that it is again 2.11. We can construct a z. It is not needed in my exercise, but you can construct z for the sampling distribution of mean. It is equal to x bar minus mu x bar divided by sigma x bar. And in this exercise, x bar is a variable. I am just leaving it as x bar, but the value of mu x bar and the mu are identical according to the theorem. And the standard error is, in case of with replacement, it is equal to sigma upon n root. So the value, the expression for the z statistics will be x bar minus 4.66 divided by standard error, and the standard value of the standard error is 2.11. This is the standardized expression for the sampling distribution of mean.